Okay, so we are very familiar with the y-intercept of a line. We know that it is where the line crosses the y-axis, and we know how to find it on a graph. So we come over here, this line crosses the y-axis at 5. Now we generally have said the y-intercept is 5. Today I want you to write it as an ordered pair. So the x-coordinate is 0, the y-coordinate is 5. So the coordinates of the y-intercept are 0, 5. All right. Now we have completely ignored the x-intercept so far, but the x-intercept usually exists, and that would be wherever the line crosses the x-axis, right? Makes sense. So where the line crosses the x-axis. So we look at this line, and this line crosses the x-axis at -4. So we can say the x-intercept is -4, but I want you to write it as an ordered pair, and the coordinates of that point are -4, 0, right? So the x coordinate is -4 and you don't go anywhere up or down. So the y coordinate is 0. So I want you to write your answers today as ordered pairs so that you do not lose sight of the fact that the y-intercept has an x coordinate and the x-intercept has a y coordinate. Okay, so we're going to learn how to do this 3 ways. We're going to do it from a graph, which is very simple, just like that. You're going to look at the graph and give me the coordinates of the y-intercept and the x-intercept. We're going to do it from a table, and we're going to do it algebraically. Okay, so doing it from a graph is very easy. Why don't you tell me the coordinates of the y-intercept of this blue line? The y-intercept is the point 0, 2. Now give me the coordinates of the x-intercept. The x-intercept has coordinates 2, 0. Okay, so for this line, give me the coordinates of the y-intercept and the x-intercept. So you should have gotten that the y-intercept has coordinates 0, -6, and the x-intercept has coordinates 9, 0. Okay, so from a table, we have found the y-intercept from a table many times. Remember, the x-coordinate of every point on the y-axis is 0. So we look for the x-coordinate to be 0, and that's my y-intercept. So my y-intercept is 0, 3. Well, for the x-intercept, the y-coordinate is 0, right? Everything on the x-axis, the y-coordinate is 0. So we look through the table, we find for the y-coordinate to be 0, and so the x-intercept here would have the ordered pair 6, 0. All right, so here's another table. Look at the table and tell me what the y-intercept is. Did you get 0, -4? Okay, now look at the table and tell me what the coordinates of the x-intercept are. You should have gotten the ordered pair to 0. So that's how you find the x-intercept and the y-intercept from a table. Okay, so algebraically, it's going to take a little bit of work as you would have expect. As you would expect. It's not difficult. There is just a little bit we have to show. Okay, so what do we know about the x-intercept? Well, we know for the x-intercept that y is 0. So we're going to substitute 0 in for y. Okay, so for the x-intercept, y is 0. So we're going to say 3x minus 2 times 0, because the y coordinate would be 0 for the x-intercept, is 12. This is going to give us a very simple equation to solve. Negative 2 times 0 is 0, right? So this is just going to be 3x equals 12. And then we're going to have a little one-step equation to solve. And we're going to get x is 4. So my x-intercept is the point 4, 0. The y was 0. And when y was 0, x was 4. Okay? Now, for the y-intercept, as we have said many times now, for the y-intercept, the x-coordinate is 0. So I'm going to take 0 and I'm going to plug it in up here for x. So I'm going to say 3 times 0 minus 2y equals 12. 3 times 0 is 0, so I'm left with negative 2y. Don't lose that minus sign. This is just a one-step equation. I'm going to divide both sides by negative 2, and y is negative 6. So the coordinates of the y-intercept, I'll get it in a second, is 0, negative 6. Okay, so the x-intercept is 4, 0. The y-intercept is 0, negative 6. All right, let's do it one more time. So we're going to find the y-intercept. What is true? What value do we know if we are finding the x-intercept? What should be the value of 0? I'm sorry, I just messed that up. What should be the value of y? For the x-intercept, y is 0, okay? So I'm going to plug that in, and I'll say 2x minus y is 0 equals 6. 2x minus 0 is just 2x. I'm going to divide both sides by 2. And I get x is 3. So the ordered pair, or the coordinates of my x-intercept, is 3, 0. Okay, so my actual answer for my x-intercept is 3, 0. Now, for the y-intercept, what do I know about the x-coordinate of the y-intercept? X is 0, right? So I'm going to substitute 0 in for x in my equation. So 2 times 0 minus y equals 6. 2 times 0 is 0. So I have negative y equals 6. If you remember how to handle this, this is negative 1 times y. So I'm going to divide both sides by negative 1. And I get y is negative 6. So what are the coordinates of my y-intercept for this equation? All right, and it's 0, negative 6. So interestingly, look at these two equations. They're different, but they have the same y-intercept. So if we were to graph both these lines on the same coordinate plane, I wonder what would happen. Okay, so you do these. Here's a graph. Tell me the coordinates of the tell me the coordinates of the y-intercept, and then tell me the coordinates of the x-intercept. You should have gotten that the y-intercept is 0, 3, and the x-intercept is negative 2, 0. Okay, next, here's a table. Give me the coordinates of the y-intercept. Give me the coordinates of the x-intercept. The y-intercept is 0, 9. The x-intercept is negative 3, 0. Okay, here's an equation. Negative 5x plus 2y equals 10. Find the coordinates of the x-intercept for this equation. When I'm finding the x-intercept, y is 0. I plugged in 0 for y, and I got x was negative 2. So the x-intercept is negative 2, 0. Now do the same thing, but I want you to find the y-intercept of this line using this equation. When I let x be 0, I got 2y equals 10, so y is 5. So the x-intercept of this line is 0, 5. Okay? All right, we are ready to find intercepts together in class.